Okay, geometry, welcome back. Section 4.2, angles of triangles. Okay, one of the things we want to get done here today, and that's the objective here is to apply the triangle sum theorem and the exterior angle theorem to find measures of angles. So again, just to point out, we're dealing with angles of triangles. So you're not really going to be dealing with the sides here. You're going to be dealing with the angles. And so triangle sum theorem is one theorem you're going to be working with, and the other one is the exterior angle theorem. Okay, in order to do that, we have to know what an exterior angle is. So that's our first definition here. What is an exterior angle? This is an angle formed by one side of the triangle and the extension of the adjacent side. So you can see down here in your example, the picture, angle 1 is your exterior angle because it is formed by one side of the triangle, this bottom side, and the adjacent side here kind of forms that. So here's the side of the triangle, and its adjacent side, it kind of extends along that, right? And then this is the adjacent side that extends out to make it the exterior angle, okay? And then remote interior angles. They're the two angles that are not adjacent to the exterior angle. So in that diagram, you can see the angle 2 and 3. They're not next to angle 1. Those would be considered the remote interior angles. Then we're going to talk about a couple corollaries today as well. And corollaries are simply a statement that's easily proven by a theorem. Okay, easily proven by a theorem. It's just something that we can easily prove just by using the theorems before that, okay? So let's continue on and do some examples here. And first get these two major theorems out of the way. The first theorem here is the triangle sum theorem. And in words, that is basically the sum of the three interior angles of a triangle is 180 degrees. And I think a lot of you already knew that, but basically it's just telling you that all three angles of a triangle, interior angles, will add up to 180 degrees. So an example would be to draw a picture here, and then let's do this and this. Okay, and if we said that this was, say, 20 degrees in here, and this is kind of how you're going to solve some of these problems. Let's say this was 120 degrees in this angle right here. Okay, well, and it's an obtuse angle. Let's say that this is x, and we didn't know what this was. Well, we can easily find that because we know they have to add to 180. So I could find that by saying, all right, 120 plus 20 is 140. So what's left over? There would be 40 degrees. So x would have to be 40 degrees here. Okay, because 180 minus 40 is 180 minus 140 is 40. So you can easily find the missing angle using that theorem. Okay. The next theorem we're going to discuss is the exterior angle theorem. And this one basically says your exterior angle is equal to the sum of the two remote interior angles. Okay. So if we just had an example here, let's just draw a triangle. And then let's just extend this side out here so we can have our exterior angle. And we'll say that that's x. Okay, we'll call that x. And then we'll call this interior angle here, we'll call this y. And then we'll say that these are 50 and 60. Okay, well, we know I can find what y is, right? Y would just add these up and subtract from 180, and I'd get it. But for x, I know x is the interior angle, so x would be equal to the two remote interior angles of 50 and 60 here. So x would be 50 plus 60, so x would be equal to 110 degrees. Okay. The reason I put y in there also is that you can see that x and y together here, together x and y would make a straight line. And so y would have to be 70 degrees because they would have to add to 180. Same reason why y has to be 70 degrees as well is because 50 plus 60 is 110, Subtract that from 180 and you get 70. So your exterior angle is going to be a linear pair with the interior angle adjacent to it. Okay? But we know the exterior angle is also the remote interior angles added up. All right, your triangle sum corollaries. All right, a couple of them, and they're pretty easy to prove. The acute angles of a right triangle are complementary. Okay, so if we're dealing with a right triangle, and you can remember complementary means they're equal to 90 degrees. Okay, and if we're looking at it, okay, if you think about an example where we have a right triangle, and do that here, so we got my right angle here. If we are looking at, let's call this X right here, and let's say this is, say, 35 degrees in this angle here, okay? Well, we know that this is 90 because the box, right, makes that 90 degrees, and so I can say, well, X plus 35 would have to be 90 as well. So what plus 35 equals 90? Well, they have to equal 90 because this angle here is 90 degrees. We know that. And to get 180, then 35 plus x has to equal 90. So therefore, we can figure it out right away that x would have to be 55 degrees because 55 and 35 would equal 90. Plus you add the right angle in, that's another 90 to get your 180 for the triangle. Okay? The next one, corollary, is there can be at most one right or obtuse angle in a triangle. And the key phrase here is at most. At most. Okay, at most one. So you can only have one right angle or obtuse angle in a triangle. Okay, you don't have to have any. That's what at most means. If it's an acute triangle, it's not going to have any right angles or any obtuse angles. But if it's a right triangle, it only has one right angle. If it's an obtuse triangle, it only has one obtuse angle. So let's take a look at some examples that would prove this to be correct. Let's try to have two right angles in a triangle. Well, we know triangles have three sides. So if I took this right angle here, okay, made that a right angle, then my third side has to be a right angle. Well, it's not a triangle. So I have a 90 degree and a 90 degree angle. Well, that's not going to be a triangle. So because the three sides don't touch. Okay, so that's one example. The other one would be with the obtuse angle would be, let's draw an obtuse triangle here, or obtuse angle. Let's try this. If I go here to here, that's an obtuse angle, right? Let's show that by this greater than 90 there. And then let's say I went, out here with this one, okay, and another obtuse angle. Well, again, those three sides do not make a triangle, so that kind of proves that theorem to be correct. Okay, now let's use some of these theorems to solve problems, and let's just do number one here. You guys can, or letter A. You guys can do B on your own if you feel like it, and let's take a look. So angle 1. Well, angle 1 we can tell by adding up 74 and 43 and subtracting from 180 because they all have, remember, they have to equal 180 degrees in a triangle. So by doing that, I can say, all right, 74 plus 43, and to subtract that, I'm going to get 63 degrees in here for angle 1. Go ahead and do that if you want. You end up getting, I think, 117. When you add those up, subtract that from 180, you get 63. Okay, so I know that angle 1 is 63 degrees. Angle 2 also has to be 63, and this is going back a little ways, but vertical angles are congruent, and so 1 and 2 are vertical, so they would have to be congruent. So you kind of got to rely on some prior knowledge. And then we could find angle 3 pretty easily by saying that, well, I've got a 79 and I have a 63, so I can add those up and say, well, I'll take my 180, and then 79 plus 63 is equal to 142. So what does that equal? It ends up equaling 38 degrees for angle 3. Okay? Next, let's go skip B and go to this one. All right, so we can use a lot of different theorems here. This one, if we look at angle 1, I'm going to use the exterior angle theorem for angle 1. Okay, so I'm looking at this one first here, angle 1. All right, and what I'm looking at is the exterior angle theorem is going to tell me that if I add up 50 and 78, that's going to give me angle 1. So I can tell right away that angle 1 is going to be 128 degrees. All right. Now I also could figure out this angle in here to be, I think, 52 degrees, because that's the missing triangle. 50 and 78 add up to 128, and then that would be 52. Also, this 52 degree angle has to be supplementary with angle 1 because they would make a straight line, so I know it's 52. Which then helps this angle and angle 2 have to be 52 as well, because it's vertical to the angle we just found. So angle 2 would have to be 52 degrees. All right, now let's move on to angle 3. If I'm trying to find angle 3, I know that this 120 that's sitting over here, this 120, is an exterior angle, so that would equal this 52 here plus angle 3 here. So it's basically going to be 52 plus x equals 120. So what, basically if I subtract 52 from 120, I would get angle 3 to be 68 degrees. Because that 120 here has to be equal to angle 2 plus angle 3. And since we know what angle 2 is, we can figure that one out. Angle 4. The easiest way for me to do angle 4 is know that it's a linear pair with the 120 to give me 60 degrees. Because they would have to equal 180 as a straight line. And then for angle 5, I can add up angle 4 and the 56, because it would be remote interior angles. And it would be 60 plus 56 equals 116 degrees. So a bunch of different ways to do that using the theorems that we discussed today. Okay? Now let's do one more together, and we'll leave one more for you. Find the measure of angle FLW. All right, so if we look at this angle here, this is an exterior angle. It's a large angle, and it's exterior of the triangle. If you remember when we talked about exterior angles, it's that the exterior angle is equal to the sum of the remote interior angles. Right? That's the theorem we kind of talked about. So this entire angle that we're just discussing here, this angle here, has to be equal to the sum of x and 32 degrees. So if I take this 2x minus 48 and set it equal to those two remote interior angles, x and 38, and the sum of them, then I can use algebra to solve for x. All right, so let's go ahead and do it. I'm going to subtract, I'm going to subtract an x here, subtract an x here, and so that's going to, and then I'm going to add 48 to both sides using algebra. So this is going to give me x, and this is going to give me 80. 38 plus 48, or excuse me, it should be 32. I'm sorry, yeah, good. Way to catch that. 32 plus 48 is going to be 80, okay? So now that I know that x is equal to 80, I can take this 80 and plug it into this x right here, and I end up with 2 times 80 is 160, minus 48 is 112. So angle FLW is equal to 112 degrees. Okay? So that was a nice little problem involving that. All right, this one here, find the measures of each numbered angle. I'm going to let you kind of try this on your own. If you can't get it, bring it in. We'll kind of work on it tomorrow together. Just find angles 1, 2, 3, and 4, okay, using the theorems that we learned today, okay? And you might be able to use the corollary theorems, the corollaries to those theorems as well. All right, so that does it for this section. And again, work hard, rewind, see what you got to do, rewind, rewrite, keep trying, and then bring your questions to you. We'll see you next time. Thanks. Bye.